We're still working with identities. Now we have another list of identities. The most important ones that we're going to be looking at here are the double angle identities, so make sure you get these down on your formula sheet or your formula card that you can refer back to. It's nice to have these right in front of you at all times. A couple things I'd like to mention here. There's 3 different identities for the cosine of 2 alpha. That's why they're called double angle, because on the left I have double the angle that I have on the right. There's one for sine and there's one for tangent, but there's 3 separate ones for cosine. So go ahead and hit pause and make sure you get these copied down. The other ones that we're going to be looking at are product to sum identities. We won't be using these so much. And then lastly, we'll be looking at sum to product identities. So go ahead and hit pause and copy down the product to sum. And then hit pause again and copy down the sum to product. But again, the double angles at the top are going to be the ones that we use the most often today. And when you copy these onto your notes, make sure you put the notes that say, or the heading that says sum to product identities. You know, don't just have a whole huge list of identities without any identifiers on there. So we're going to use these identities the same way that we've used our previous identities. We're going to use them to rewrite expressions, solve, and verify or establish identities as well. So let's go ahead and look at a couple of examples to get started. So for our first problem, let's go ahead and look and see what information is provided. And what they're going to ask us to do is to find the sine of the double angle sine 2 theta, cosine 2 theta. So find sine theta, or sorry, sine 2 theta and cosine 2 theta given. And what we're going to be given then is that the sine of theta is equal to negative square root of 5 over 7. So don't forget that negative. And we're also given the information that the cosine of theta is less than 0. So in order for us to find the sine of 2 theta, let's go ahead and look at our formulas for these. So I'm going to paste these in and then I'll shrink these up, because we're going to want to refer to these often, so I want to have a little copy over here. Okay, so here, if I look at these, the sine of 2 theta would be this one right here. I only have one option for the sine of 2 theta. But for the cosine of 2 theta, I have 3 options, but only one of those options just involves the sine. And that's all I was given here was the sine. So I think I'm going to use these 2 right here. So this one I had no choice. I could have chosen any of these 3, but this is the fastest one, because the other ones I'd have to figure out what cosine is to use them. So let's go ahead and find the sine of 2 theta first. The sine of 2 theta, I need the sine of theta, which I'm given, and I also need the cosine of theta, which I'm not given. So let's go ahead and find the cosine of theta. So I can use the sine squared identity plus cosine squared identity equals 1, the Pythagorean identity. So I have negative root 5 over 7 quantity squared plus cosine squared equals 1. So solving for cosine, and remember cosine is less than 0, meaning negative, so I know I need to take the negative root here. I'll have 5 over 49 plus cosine squared of theta equals 1. Cosine squared of theta equals 1 minus 5 over 49, which would be 49 over 49, finding a common denominator, minus 5 over 49, which is 44 over 49. So I have cosine squared of theta equals 44 over 49. Take the square root and I'd get cosine of theta equals square root of 44 over the square root of 49, and this is going to have to be negative, because again up here I'm given that the cosine is negative. So continuing to simplify, I have cosine of theta equals negative. Now root 44 will simplify to root 4 root 11. I'll factor out any factors that are perfect squares. And then the square root of 49 is 7. So I'm given that the cosine of theta equals negative 2 square roots of 11 over 7. So I'm going to use this value for my formula way back up here. So in order to find the sine of 2 theta, again I'm going to use this identity up here. That's 2 sine of theta cosine of theta. Now I was given the sine of theta was negative root 5 over 7. And I just calculated that the cosine of theta was negative 2 square roots of 11 over 7. Now if I multiply everything together here, I'd have a negative times a negative is a positive. 2 times 2 is 4. Root 5 root 11 is root 55. And 7 times 7 is 49. So the sine of 2 theta here is 4 root 55 over 49. So this is the sine of 2 theta under those conditions. Okay, now the next thing I was asked to find was the cosine of 2 theta. Now remember, I had three formulas I could have used up here for the cosine of 2 theta. I chose to use the middle one because I was provided with the sine, and now I have the sine. And you might say, well, you just found cosine, you could use that, but I could have a mistake. I could have found a mistake when I was finding cosine, so it's probably better to use the exact value that you were given. So the formula for the cosine of 2 theta that I want to use then is going to be 1 minus 2 sine squared of theta. Now sine, again, was given to us. It was negative root 5 over 7 squared. And so simplifying, I have 1 minus 2 square root of 5 times the square root of 5 is 5. 7 squared is 49. So continuing to simplify, I have 49 over 49. I have to find that common denominator. Minus 10 over 49 is 39 over 49. And this is the cosine of 2 theta. And again, I would get the same answer if I had used one of the other formulas. But again, I could have made a mistake when finding the cosine of theta above, and then if I would have used it in my next step, I would have had a mistake as well. So it's usually best, if you can, to use the information that's given and not rely on the information that you've calculated, because you could have a mistake in there. Okay, so let's do a similar problem to that. In this one it says use the functions to find sine theta and cosine theta given, and I think we can fit this here, cosine 2 theta is equal to negative 40 over 41, and I'm in quadrant 1 for theta. And you might say, well, wait a minute, how can cosine be negative here in quadrant 1? Well, I'm doubling cosine. So when I double it, I must probably end up in quadrant 2, it looks like to me. So let's go ahead and look at our formulas here. Again, I want to use these. And when I look at these, I have three options for cosine. I have these top three options for cosine. But I'm trying to find sine, so it looks like to me the best one to use to find sine would be this one right here. Okay, so I have cosine of 2 theta, and I should be able to solve for sine. So let's go ahead and start with that. So the cosine of 2 theta for my formula is 1 minus 2 sine squared of theta. The cosine of 2 theta I was given is negative 40 over 41. Equals 1 minus 2 sine squared theta. So what I'm trying to do here is to solve for sine theta. That's what I'm trying to figure out. I'll put that up here so we can remember what we're up to. Okay, so looks like I could subtract 1. I'm going to put my variable on the left over here. So I'm going to have negative 40 over 41 minus 1. Need that common denominator, so minus 41 over 41. So this would be a negative 81 over 41. And then I'll divide both sides through by a negative 2. So I'd end up with sine squared theta equals negative divided by negative is a positive 81 over 82. Now it says I'm in quadrant 1, so when I take my square root of both sides, I'll get sine theta equals plus or minus root 81 over root 82. And I'm in quadrant 1 for angle theta. So I know that I'm going to choose the positive here. So I will get sine theta equals the positive square root of 81 is 9. Square root of 82, I don't think there's any factors that are perfect squares. 4 doesn't go into it evenly. So we'll just leave it as 9 over root 82, and we'll rationalize that denominator. So this means that sine of theta equals 9 square roots of 82 over 82. Okay, so now we have solved for sine theta. The next thing we need to do is to solve for cosine theta. So let's make some room. So solve for cosine theta. So if we look at our formulas up here, again, I'm going to use one of these top three probably. I think our best bet would be to use this third option right here, because I know cosine of 2 theta, or 2a, either one, and when I plug in, I should be able to solve for cosine straightforward. So let's go ahead and use that one. That would be cosine of 2 theta is equal to 2 cosine squared of theta minus 1. Now remember, the information that I was given is that the cosine of 2 theta is negative 40 over 41. So for here I'd have negative 40 over 41 is equal to 2 cosine squared of theta minus 1. Now our goal here is to isolate cosine squared, to get that by itself, and then to go ahead and take the square root of both sides. Okay, so let's go ahead and do that. I'm going to put my variable on the left, the 2 cosine squared theta, that's just my preference, equals negative 40 over 41, and then I'm going to add the 1 across. And then I'll find a common denominator, so this would be plus 41 over 41. Negative 40 plus 41 would be 1 over 41. Divide both sides through by 2, and I'd have cosine squared of theta equals 1 over 82. Now I take the square root of both sides, and when I take the square root of both sides, I have to remember which quadrant I'm in. So I'd have cosine of theta equals plus or minus the square root of 1 over the square root of 82. But I'm in quadrant 1. So if I'm in quadrant 1 here, for angle theta, that would mean I would look at the positive root here. So cosine of theta would be square root of 1 is 1 over the square root of 82. I'd rationalize that denominator, and I'd get the cosine of theta is the square root of 82 over 82. So that's the other value that I'm looking for. So again, the cosine of theta is the positive square root of 82 over 82. So again, we're using a lot of information we've used previously in other sections in terms of using the values to solve. You know, we're using a lot of algebra here, but it's pretty consistent to looking at all the problems that we've looked at before with identities. So we're just applying new identities, not really any new types of problems or new work. So for this one, let's go ahead and find the exact value. And find the exact value means there has to be probably radicals, fractions involved. We're not looking at just plugging this into your calculator and getting a decimal, but you could use it to check. So I'm going to have the value of 2 times the sine of pi over 6 times the cosine of pi over 6. So let's go ahead and look at our identities again. Again, it's handy to have these on a note card nearby. And we'll see that this looks like 2 sine theta cosine theta, and that's right here. That's this right-hand side right here. So what I can do is I can say, okay, well that expression then, this 2 sine pi over 6 cosine pi over 6 is equal to 2 sine, or sorry, is equal to sine of 2 times my angle. That's from right here. That would be sine of 2 times pi over 6. So the sine of 2 pi over 6 is the sine of pi over 3, and the sine of pi over 3, and again this is a standard angle that we know, is the square root of 3 over 2. Okay, so I can use the standard angle here, and knowing our standard angles in our unit circle is absolutely crucial. Okay, again, I want to make sure that we go through all the different types of problems that you might see in your homework set, so let's look at more problems. For this one, we're asked to find cosine of 2 theta and the sine of 2 theta. And this one we're given that the sine of theta is root 2 over 7. And we're also given that the cosine of theta is negative, so it's less than 0. Okay, so let's go ahead and look at our little double angle identity card sheet here. It's going to come in handy. And for this one, let's go ahead and start with the cosine of 2 theta. I think there's several different ways that we could work through this one. But let's look at the cosine of 2 theta to start. Now if you notice, I have 3 different options here. We're given information about the sine, so I think this is our best option to use. So I'm going to use this one. I'm going to use this double angle identity. And as usual, it's important to always state which one you're using so I know which one you're plugging into, and that way I can check for that work. Now the cosine of 2 theta is what I'm actually trying to solve for. Sine I'm given is root 2 over 7. So go ahead and simplify, and that's squared. 1 minus 2, root 2 is root 4, which is 2. 7 squared is 49. So 1 minus 2 times 2 is 4 over 49. So this is 49 over 49 minus 4 over 49 is 45 over 49. So the cosine of 2 theta is 45 over 49 here. Now I could have used other ones. I could have gone through and solved for cosine using, the right triangle, etc. But I think this is a pretty straightforward approach, is to use the information that's given because we know it's accurate, and then choosing from there how to solve. Next we're going to look at the sine of 2 theta. Now the sine of 2 theta is going to be 2 sine theta cosine theta. I only really have one option here. Okay, so again, I'm trying to find the sine of 2 theta. So 2 sine theta cosine theta. I'm given that the sine of theta is root 2 over 7. And apparently I just need to figure out what the cosine is now. So I have to figure out what the cosine of theta is. Now in order to find the cosine of just theta, I could come up here because I just found the cosine of 2 theta, and I could plug into here to solve for cosine of theta. That would be an option. Another option would be to go after our Pythagorean identity of sine squared plus cosine squared of theta equals 1. Well, we were given sine of theta, so I think this would probably be our better approach. So this would be the square root of 2 over 7 squared plus cosine squared equals 1. So I have 2 over 49 plus cosine squared theta equals 1. These are not short problems. So cosine squared theta equals 1 minus 2 over 49. Finding that common denominator would be 49 over 49 minus 2 over 49 would be 47 over 49. Now of course I need to take the square root next, but let's run up and see here. It says cosine of theta is less than 0. So that means I'm going to be able to take the negative root here. I have 2 roots, so it would be root 47. Square root of 49 is 7. And again, I was given that this is negative. That information was provided. So this is going to be a negative square root of 47 over 7. And that value will plug in up here, negative square root of 47 over 7. Okay, now simplifying, across the top I have a negative times a positive times a positive. That leaves me with a negative square root. 47 times 2 is going to be 94. And then 7 times 7 is 49. So this is negative 2, sorry I forgot the 2 from right here, root 94 over 49. This is the cosine, sorry, this is the sine of 2 theta. That was the other one that we were asked to find. So again, there's more than one approach to take with some of these, but what you need to make sure is you're always showing your work and explaining your work as you go, especially on exams, because that's what you'll be graded on. You really won't be graded on the final answer. It will be more on your work on how you got to the final answer. So again, always make sure that you are writing down what identities that you're using. So this one, let's go ahead and find the exact value. And this will be the exact value of 2 cosine squared of 157.5 degrees. Now this one, I'm finding the exact value. This does not look like a standard angle. And then minus 1. So hopefully I can relate this to some sort of an identity. So 2 cosine squared minus 1. Okay, that's definitely this one right here. 2 cosine squared minus 1. So that's the identity that I'm going to use. So the cosine of 2a is equal to 2 cosine squared of a minus 1. Now notice you need to put parentheses around the arguments of your trig function so that we understand the minus 1 is outside the argument. So I have the right hand side here. That's what's given to me, 157.5 degrees. So this angle over here has to be twice that. So over here I'd have 2 times 157.5 degrees. Taking 157.5 times 2 is going to leave me with 315 degrees. So the cosine of 315 degrees. Okay, well this is actually a standard angle. You might not remember it or recognize it, but it is a standard angle. So let's go ahead and put up our Cartesian coordinate system. 315 degrees, here I am at 270. To get to 315, I would have to add 45 degrees. That makes my reference angle right here a 45 degree reference angle. Because remember, the reference angle is the distance to the nearest horizontal, so that's this orange right here. So cosine is positive. So the cosine of 315 degrees is going to be positive in the fourth quadrant, and it's going to have the same cosine as 45 degrees. So the cosine of 315 degrees is the square root of 2 over 2, and it will be positive because I'm in the fourth quadrant. So that's an example of finding the exact value. Sorry, that's my dog playing with her toy. So that's an example of finding the exact value. You could plug this in to your calculator to find a decimal approximation, but square root of 2 over 2 is the exact value. Okay, let's go ahead and look at another example. Now we've usually been looking at sine and cosine. For our next one, let's go ahead and look at a tangent. So we want to simplify this expression. We want to simplify the tangent of 12 degrees over 1 minus tangent squared of 12 degrees. Now let's go ahead and look at our little note card that we keep popping in here. The only one that this even looks remotely similar to is this bottom one with tangent. So I'm pretty sure we're going to be using this. However, it's not quite the same. If you notice, there's this 2 here that is not showing up in our expression. So we have this 2 right here. So let's see if we can do some rewriting. So the tangent of 2a is equal to 2 tangent of a over 1 minus tangent squared of a. Now the problem that we have is we don't have this 2 right here. So really what I could do is I could think about is multiplying this times a half to clear that 2. And again, whatever you do to one side, you have to do to the other. So then the 2's cancel, and I'd be left with the tangent of 2a over 2 is equal to the tangent of a over 1 minus tangent squared of a. So now this matches what I'm given up here in my original problem. So we have, in this particular problem, a value for a. So here I have the tangent of 12 degrees that was given to me over 1 minus tangent squared of 12 degrees. So what this means then is 12 degrees is equal to a. So I have the tangent of 2 times 12 degrees over 2. So this is the tangent of 24 degrees over 2. Now I can't cancel the 2 into the 24 degrees because the 24 degrees is inside the argument of the trig function, and I can't just arbitrarily multiply and divide that argument with any numbers outside. It all has to take place within the argument of the trig function. So that was an example of simplifying. We needed to do a little algebra up front first. We'll have another problem where we have to do a little algebra up front. This one would be 1/8 minus 1/4 sine squared of 43.1 degrees. Now please always put parentheses around the arguments of your trig functions. It makes them a little bit easier to work with, and it makes it easier for me to see clearly what you think the argument is and to give you all sorts of credit for that. So if we look to see what's going on here for this one, this looks like something minus sine squared. Okay, so that's probably about the closest we can get is right here. So let's go ahead and use cosine of 2a equals 1 minus 2 sine squared of a. So again, we're trying to figure this out. Cosine of 2a equals 1/8 minus 1/4 sine squared of 43.1 degrees. Well, if we would just take this expression right here and divide it by 4, I'd get my, no, that didn't work. I'd have to divide by what? 8. So if I divided by both sides by 8, then this expression would work. I'd have 1/8 here, 2/8 is 1/4, and this would work perfect. So I'd have the cosine of 2a over 8 equals 1/8 minus 1/4 over sine squared of 43.1 degrees. So then this matches perfectly. So in place of this a then, I should be able to put times 43.1 degrees. So 2 times 43.1 degrees then would be the cosine of 86.2 degrees over 8. So that's what this simplifies to. And again, that was taking our original and rewriting one of our double angle identities. I had to divide both sides through by 8 to make it match. But then I can look at this as a rewrite of cosine 86.2 degrees all over 8. And again, I cannot divide the 8 into anything. I have to leave it as is because I can't mess with the argument of a trig function. Let's look at another example. This one, we're just going to rewrite this. And we want to rewrite this as a function of x. So I don't want a 3x or a 2x, I just want an x. So first of all, I notice that I could rewrite this as 2x plus x, and this would be the sine of a sum of angles. Okay, so look back on your note card, and what we'll use here is the sine of a plus b is equal to the sine of a cosine of b plus cosine a sine b. Hopefully that'll fit on there. So this rewrites as the sine of 2x plus x is equal to the sine of 2x cosine of x plus the cosine of 2x times the sine of x. Now remember, we have to rewrite these as a function of x, and I almost have it. I have two of these with a 2x though. So let's go ahead and keep rewriting. The sine of 2x, if I come and look up here, I guess I could put down another little formula card right here, a little closer. The sine of 2x I can rewrite as 2 sine x cosine x. So this is my double diagonal identity, 2 sine x cosine of x. And of course this one I would leave the same. This one I'm going to have to rewrite though. And when I rewrite the cosine of 2x, I have 3 options. These 3 options right here. So I could really choose any of them. I think that this one, since everything is in terms of sine and cosine, I'm going to choose this top one and see if it helps me get this simplified. So I'm going to use cosine of 2x is equal to cosine squared of x minus sine squared of x. So this is 2 sine x cosine of x times cosine of x. Again, that's this piece right here. This from right here. Plus cosine squared of x minus sine squared of x. Now this entire thing, so I need to put this in brackets, is multiplied by sine of x. And then I'll distribute. So it looks like I have 2 sine of x cosine squared of x plus sine of x cosine squared of x minus sine cubed of x. And that's from taking this sine of x and distributing through to here and to here. So it looks like to me everything's in terms of just x right now. Sine x cosine squared. I think I should be able to maybe combine these a little bit more. I have this sine cubed of x as well. Wait, my eye just caught something that might be a mistake. Let's check that. Let's see. Okay, I don't see any mistakes, but I do see that I could rewrite this in terms of sine. So maybe I should try and get everything in terms of sine. So I could rewrite that in terms of sine. And this one using the Pythagorean identity, sine squared plus cosine squared is 1. So cosine squared is equal to 1 minus sine squared of x. Okay, so let's rewrite there. So I have 2 sine of x times 1 minus sine squared of x. You need to make sure you put up the brackets. Without the brackets, then it won't distribute correctly. Plus sine of x, 1 minus sine squared of x, minus sine cubed of x. Okay, so distributing, I get 2 sine of x minus 2 sine cubed of x plus sine of x minus sine cubed of x minus sine cubed of x at the end. Okay, so what I'm doing is I'm taking this, I'm distributing here and here, taking this, distributing here and here. Now what I should be able to do is to hopefully combine some things here. Here I have a 2 sine of x plus sine of x is a 3 sine of x. That's here and here. Negative 2 sine cubed of x minus sine cubed of x is a minus 3, and one more would be a minus 4 sine cubed of x. So now I have everything simplified not only just in terms of x like our instructions say, but all in terms of sine. So sometimes it's kind of hard to know where to stop. A lot of times in my math lab they'll give you several different options, and so you'll need to know you have to keep going because your option that you found isn't being listed. Okay, so let's see. A lot of these, again, is a lot of algebra. You're going to be using a lot of algebra for these. And they give you some hints like filling in the blanks. But be careful when you're working through the algebra. One of the things that I can definitely suggest is you always work through the problem step by step. Don't skip any steps. And then again, always put parentheses around the arguments of your trig functions so that way they don't combine incorrectly. It's a common mistake. So let's go ahead and look at one where we're verifying the identity. Now remember, with verify the identity, you usually start with the more complicated side and then you work toward the simpler side. So for the identity that we want to look at, let's look at the sine of 32 alpha equals 4 sine of 8 alpha cosine of 8 alpha cosine of 16 alpha. So on this one, I definitely think the right-hand side is more complicated. So let's go ahead and start with that. We're going to start with this right-hand side. So 4 sine 8 alpha, cosine 8 alpha, cosine of 16 alpha. So to simplify here, I could look at this and I could kind of see like a 2 sine alpha, cosine alpha. I'll pop that note card up here again real quick so we can see what I'm referring to. I'm kind of looking at this right here on the right hand side. This kind of looks like that. The only thing it looks like that we're off by is that instead of a 2 we have a 4. So what I could do is I could take this 4 sine 8 alpha cosine 8 alpha, and those arguments have to be the same, and they are in this case. That would equal the sine of 2 alpha. Actually, it's going to be double that, so it's going to be 16 alpha over here. And then this has to be a 2 in order for this to work. So I'd have to take this 4, and in order to make it into a 2, I'd have to have basically a fraction over here on the other side. So let's go ahead and see if we can simplify that. Now we really don't want to involve any fractions, so I think instead of dividing through by 2, let's rewrite this a little bit different. Okay, so this doesn't quite work the way that it is. If I wanted the sine of 16 alpha, that would be 2 sine 8 alpha cosine 8 alpha. So what I'm missing here then is I want a 4. So I'd have to multiply both sides through by 2 as another option to force that in. So I think I like this better than using a fraction. So I'd end up with 4 sine 8 alpha cosine alpha is equal to 2 sine 16 alpha. So this entire expression up here simplifies to 4 sine 16 alpha, and then of course I have this cosine 16 alpha on the end. I'm going to do the exact same thing again. So I'm going to have the sine, this is going to be 32 alpha because I double here on the left, is equal to 2 sine 16 alpha cosine 16 alpha. But again, I don't want a 2, I want a 4, so I have to multiply both sides through by 2, and I end up with 2 sine of 32 alpha is how this simplifies. Okay, so when we're working through these, I think what ends up happening is that you have to just keep simplifying down till you get to that basic value. And actually I think I copied this down wrong. So from here to here, it should be a 2. Sometimes I don't catch these until I look at them. So this, I'm just copying this down from 2 sine 16 alpha. And then the cosine 16 alpha came from up here, so I don't have to multiply by 2 because I only have a 2 on the other side. So this should just be sine of 32 alpha. So again, another example where you're verifying an identity. Make sure you're careful about keeping track of things, more careful than I just was. And let's do one more of these, just because I want to make sure that you have plenty of things to look at when you're working through your homework. So this one we have the tangent of 4x plus the cotangent of 4x equals 2 cosecant of 8x. Okay, so start with the more complicated side. In this case, I think that's the tangent cotangent. So I could take tangent cotangent and I could rewrite that as sine of 4x over cosine of 4x plus the cosine of 4x over the sine of 4x. So that is simplifying this left-hand side right here. Okay, so next from there we could find a common denominator. So if I find a common denominator, basically I need to multiply this by the sine of 4x top and bottom. And then on this side it would be times the cosine of 4x. So simplifying from there, I'd have sine squared of 4x plus cosine squared of 4x all over sine x sine of 4x, cosine of 4x. And then Pythagorean identity, this is equal to 1 over the sine of 4x, cosine of 4x. And of course I need to justify that, and you'll need to do that too. This piece right here is equal to 1 because this is equal to sine squared of theta plus cosine squared of theta. So it doesn't matter what the argument of the angle is as long as it's the same. And then from here I can rewrite this 1 over sine of 4x cosine of 4x. This almost looks like, let's go ahead and pull this in again. This piece right here is just in the denominator. And the only thing I'm missing there is a 2. So I'm going to go ahead and multiply top and bottom by 2. So rewriting there, I'd have 2 over 2 sine of 4x cosine of 4x. And this would simplify then to the sine of 2 times 4x, or 8x, and 1 over sine is cosecant. So this is 2 cosecant of 8x. Now if you notice, the only thing we really used on all of these were these double angle identities that I kept pasting in. We never used the product to sum or the sum to product. Those are nice things to have on your formula sheet, but really the double angle identities is what we'll be using a lot more often. So as usual, if you have any questions, please let me know. Take a screenshot of the problem and a screenshot of your work, and good luck.